The goal of this project was to create a touchscreen MP3 player utilizing the DE2 development board, a touchscreen LCD, and a hardware MP3 decoder. The following video is a demonstration of the capabilities of the MP3 player. Some of its features include karaoke, being able to play WAV, and MP3 files. The touchscreen is used to interact with the GUI. When the player is initialized, a welcome screen is displayed. From here, the user can choose between the standard MP3 player and the karaoke function. The MP3 player allows for a typical navigation and control settings, including play, pause, stop, next song, previous song, volume up, and volume down. As you can see, as the screen is touched, the 7-segment displays change. The X and Y coordinates of the last position touched are displayed. These are used to determine if a button was pressed. The rest of the video is a demonstration of the functionality of the MP3 player, including song navigation, volume control, and the karaoke function.
Almost heaven, West Virginia.
When the karaoke function is selected, the microphone is turned on and the user is allowed to sing along with his or her favorite songs.
It works, as my voice is amplified.
There's no words in this one. Gotta go to the country one, so. Not there.
Not this one?
This voice. It's not country. Is this the Dolly Parton song?
Well, it works. That's what we wanted to cover, was that it works. All right.
This is a NEOS development environment. We have here on the left-hand side two projects actually. Two projects for two processors. One's for the video and one for the audio. And this is the code for the audio. It's divided into different files. Basically, and then they have the video processor code as well. There's different files here. Programs, you can program it, and this is where the C code development was being done. This is actually on this Eclipse platform. One of the examples of say that the video processor file is right here. This is where the GUI for the C code for the video processor is written. It's the main file. As an example of the audio processor's main file is right here. It connects. It connects to an SD card, to the MP3 decoder, and a lot of functionality here. What we hear in the core is the SOPC builder.
Explain that you have two processors.
Yes, I do. So we have I'll show you the system layout here. is booting up, there's two processors in the system, the video and the audio, and then there's a whole bunch of peripherals associated with them. Some of them are like memory for each processor is different. One has SDRAM, the other one has on-chip. There's a lot of LCD controller functionality from for the video processor. As you can see here, this is the audio processor. It's connected to on-chip memory, has an NPU controller to configure the codec, SPF peripheral to talk to the MP3 decoder, SD card where it pulls the data from, has parallel ports to communicate with the decoder. Then there's a video processor, has a pixel buffer, DMA, and a whole bunch of other peripherals that actually make the video processor work. A lot of the LCD controller functionality was pulled from reusable, off-the-shelf IP blocks. It connects to SD-RAM, and then there's another on-chip memory that is shared between both processors that allows communication to happen between them. And that is it. That's basically the interconnect system of the processors and their peripherals. So this is our MP3 decoder. We designed this board from way out, and it connects way out, designed it, weighed it out, and actually manufactured it. We're using a SparkFun Electronics VS-1053 MP3 decoder that connects through to a D2 board.
The touchscreen.
Touchscreen is actually a Terasic touchscreen that is compatible with our D2 board. It has a touchscreen capability. Its resolution is 800 by 24.
800 by 480.
By 480 by 24-bit character capability. And it also connects to the D2 board via a ribbon cable. And the D2 board has a lot of components on it. What we're actually using in this D2 board is this is our Cyclone 2 FPGA, the SD card where we're actually pulling the song files or songs from, and this can hold up to a gigabyte or so of data. We're using SD-RAM here, SD-RAM component right here. That is our video processor's code. We're storing data on, and we're using program code to store there as well. We have a codec here that we're using it receives the information from the other FPGA from the MP2 decoder in an I2S format, and basically streams it in that format to the codec, which then basically outputs it through to the line out to the speakers. The codec also has a microphone capability where it can actually add the microphone output to the speakers. So that's what we're using for the karaoke. So some of the features that we're using here: the codec, the memories, SD and SDRAM. What else?
Feedback.
Yes, feedback. And that's generally it as far as on the board goes.